So let's begin our discussion with free fall motion. So what is free fall motion? Initially, the time we were talking about linear motion, I mentioned to say we we have three main formulas, which are, I'm sure you are familiar with this. V final is equal to V initial plus acceleration times time. The second one is the displacement, which is the same as we can say distance is equal to the V initial times t plus half acceleration times t squared. Another one, we said it is V final squared is equal to V initial squared plus 2as, where s is the displacement. Now, free fall motion, it is also under linear motion. So the first part of linear motion, we are using these formulas. Now, when we're talking about free fall motion, we're talking about an object is moving. So now, I want to give you a hint. There is a topic which we're going to talk about, which is projectile motion, which we are going to be talking about the motion in two dimensions. But this is a motion in one dimension. The object is moving in either x direction only or in y direction. Now, when an object is moving in x direction, okay, I'm going to take it to say these are the formulas we're supposed to use. But when an object is moving in y direction, meaning the object can be in free fall. What do we mean when we say in free fall? You throw an object going up, it is under the influence of gravity. So that object is moving due to acceleration. So we call the acceleration due to gravity. Now, I want you to understand that g, the value of g is 9.8, but sometimes they are going to give you to say use 9.81. But if you have not been given, just use 9.8. It's meters per second squared. Now, when I'm talking about free fall motion where there is acceleration, we're going to be replacing it with g. The rest remains the same. So meaning that here, this formula, I'm supposed to replace this one with g, this one with g, this one with g. Then I'm set to go with free fall motion. Okay? Now, one more thing. When we are talking about this free fall motion, another thing we should come in your mind is that when you throw an object, or before I go there, if I have got an object which has got the mass of 5 kg, I have another object which has got the mass of 20 kg. Here is the ground. Then these objects, you throw them at the same time, or let me say with the same velocity. Between object A and object B, which one do you expect to reach on the ground first? This is the ground, the 20 kg. Why? It's heavier. Okay. So now, that is true when we talk about the reality. That is very true. But it is wrong when we're talking about the free fall motion. So, I want to give you this experiment. After this class, you can try, get a very big stone and just a small stone. At the same height, drop them. Let them go down. What you are going to observe is that both object A and B, they are going to reach on the ground at exactly the same time. So now, because these two things are going to be moving both with 9.8 meters per second squared, so they are both under in the influence of gravity. Okay, so they are going to reach on the ground at the same time, exactly at the same time. So from this explanation, we can conclude that free fall motion does not depend on mass. It doesn't depend on mass. Whether an object is big or is small, they are going to reach on the ground at the same time. This question, they like it especially for MCQ. So they reach on the ground at exactly the same time, because gravity, free fall motion does not depend on mass. Is that okay? But now let's talk more about this free fall motion. Allow me to just get rid of this, and then I'm going to, let's say you have got an object, you throw it, it goes up, it reaches at the maximum height, it comes back like that. This is the ground. Let's call this point A, point B, point C. When you throw the object, you are going to throw this object with an initial velocity, which we don't know for now. Once the object reaches at the maximum height, I'm going to assume that at point B, that's where my maximum height is. That is my H max. When the object reaches at the maximum height, the final velocity at that point is 0. Now, the object can only reach at the maximum height when the final velocity is 0. Get me right there. The object can only reach at the maximum height when the final velocity is 0. Okay? But the initial velocity is going to be there. Meaning, using these formulas, the first formula I've given you is V final is equal to V initial plus GT. The second one, the displacement, which is the height in this case, is equal to the V initial times T plus half GT squared. Then V final squared is equal to V initial squared plus 2 GT, or 2GS. So for free fall motion, S will be replaced by H because we're talking about the height. Now, I want you to understand one thing. When an object is going up, the value of G, in most cases, it is positive, is negative 9.8. When an object is coming down, the value of G is positive 9.8. What does it mean? As you are going away from gravity, so you are going against the gravity, the acceleration, the velocity is supposed to be reducing by negative 1 by 9.8 meters per second in every second. As you are coming against the gravity, the reason why when you throw an object up, or even yourself when you jump, you realize that nothing is going to be dragging you down, but from nowhere you are going to find yourself you are on the ground. It's because of gravity. So once you throw an object up, gravity wants it to come down. So when you are coming down, you are increasing the velocity with 9.8 meters per second in every second. When you are going up, you are reducing the velocity. That's the reason why when you reach at the maximum height, the velocity is going to be 0. Or it's going to be 0 meters per second, because as you are going up, the velocity is reducing by 9.8 meters in every second. So once you reach at 0, then you can't move up anymore. The only option is just to come down now. Does that make sense? Yes. Now, another thing which I want you to get familiar here is this. How do we tend to find time? You can use any formula to find time. This is the first one, the second one, the third one. You can use any formula to find the time, but I want you to understand that the time from A to B is the same as the time from B to C. Meaning that if you are asked to find the time from A all the way to C, you just get the time you find from A to B times 2. So meaning 2 the time of A to B. That will be my total time. The question they are going to ask you for you to know that they're asking to find the time from A to B is find the time it takes for it to reach at the maximum height. Meaning they're asking you to find the time from A to B. Okay? How long was it? How long was it in air? If they're asking you to say how long was it in air, they're asking you the total time it was in air. That is from A to C. It comes from A, it goes to B, then back to C. Meaning, you find the time from A to C, then times 2. That is how long it was in air. Sometimes they'll ask you to say, find the time it takes the ball to come back to the ground. It's basically the same as the time it was in air. It's making sense, right? Okay. Now from here, I think it would be better for me to use questions. From here now we can use questions. So the question which I'm going to start with, we'll start with question 11 from tutorial sheet 3. So the question is, but before you read the question, or maybe before you start solving, it is very important for you first to understand the question, because physics, the moment you miss the question, then you are done, you are doomed. So a ball is thrown direct downward, meaning that ball is from the top, right, direct downward, with an initial speed of 8 meters per second from the height of 30 meters. So what is happening here is this. Let's say this is the, let me just assume that this is a tower. Then you drop this tower, it is 30 meters. Then a ball is dropped from there. A ball is dropped from here. Now it is coming downward. They are saying that the initial speed is what? The initial speed is 8 meters per second. Okay. So it will be important for you to first come up with data after the free body diagram, because data is going to help us to know which formula we are going to use. From the information we have been given, what do you think we have? Or what do we have, in short? So we have been given the velocity, we have been given the height. What will be g in this case? Okay. Have you ever heard to say sometimes when an object is going down, g can be negative? Okay, so if you have not heard of that, then I want to show you something. I want to show you something. Okay. So there are some scenarios where when an object is coming down, yeah. So what is happening here is this. um in most cases, when an object is dropped from the top of the building, okay, when the object is coming from the ground, it will just be normal the way it is. Everything g will be negative. When it's coming down, positive. Then Again, when the object is dropped from the top of the building with an initial velocity to be 0, g will be positive. The only case where g will be negative when an object is going toward the gravity is when you have been given the initial speed when the object is coming from the top, and then you have been given the initial speed. In that case, that is the only scenario where the g is going to be negative, but the rest we are following the same principle. So what I mean here is this: if an object is coming from the top and then you have been given the initial speed there, then g will be negative. The same velocity you have been given is going to be negative. The distance you have been given is going to be negative, but the rest is the same. I don't know if I've made myself clear there. Okay. So what I mean here is I want to find time. So let's gather our data. Our data, we have got the initial speed to be 8 meters per second. We have got the displacement, which I'm going to say the height. Anyway, I'll just say d to be 30 meters. The time is the one we are looking for. What else? We have g. Now g is going to be negative 9.8. Even the distance is going to be negative, that velocity is going to be negative. The reason why the velocity is going to be negative, let me show you something. The reason why the velocity is going to be negative is because it's going toward negative x-axis. Sorry, negative y-axis. That's why it's going to be negative. Then the reason why the displacement is going to be negative as well is because if I have this, the change in displacement, or let me say the change in y, since it's in y direction, is the y final minus y initial. I want you to understand that the initial displacement, it is at this point, which is 30. When you reach here, the displacement is 0. So you have 0 minus 30, which is negative 30. That's the reason why it's going to be negative. For this kind of for this type of the question, the formula which work for you to find the time, because you have got the displacement, is this formula: v initial times t plus half gt squared. Plug in the values. The displacement is negative 30, the v is negative 8, but we don't know time, plus half. The g is negative 9.8. The t we don't know. I'll have negative 30 is equal to negative 8t minus 4.9 t squared. Shift this guy to go to the other side. So you have, so you choose this: either you shift these guys to go to the other side, or you shift this to go to the other side. It's the same thing. So meaning it's going to be, if I shift these to go to the other side, it's going to be 4.9 t squared plus 8 t squared, or t, not t squared, plus or minus 30. Then here I've remained with equal to 0. This is a quadratic equation. I don't know if I've moved so fast here, but let me know if I've moved so fast. What I've done, I've shifted this and that to go to the other side, so that I remain with 0 that other side. Then now I can use the quadratic formula. So I have that. So I'll have t will be equal to negative b plus or minus the square root of b squared minus 4ac. I divide this by 2a. So b is 8, so it will be negative 8 plus or minus 8 squared minus 4. My a is 4.9. My c is negative 30. I don't have a calculator nearby. I don't know if I can get. Do you have a calculator? Okay, let me get my calculator. Okay. So what I'm going to have here is negative 8 plus or minus the square root of 8 squared is 16. Negative and negative will give me plus, so I have 4 times 4.9 times 30, which is 588. I divide that by 2 times 4.9 is 9.8, like that. Then I'll continue from here. So I'll have negative 8 plus or minus 588 plus 16. I'm getting 604. Now what is the square root of 604? Is 24.58. I divide this by 9.8. Now let's get rid of this. So now I'll have negative 8 plus 24.58 divided by 9.8, or t will be equal to, so that is t, or t will be equal to negative 8 minus 24.58. I divide it by 9.8. Now, one thing I want you to understand here is this guy is going to give us negative time. But let's just find anyway. Then I'll explain it. So it's negative 8 plus 24.58. The answer I'm getting is 16.58. I divide this by 9.8, which is 1.69, which is the same as 1.7 seconds. Or time is going to be negative what there? Negative 8 minus 24.58 divided by 9.8. And I'm getting my time to be negative 3.3 seconds. Time can never be negative. So the answer is that t is equal to 1.7 seconds. Like that. Now, this question, most people tend to get it wrong because um, because of the same explanation I've given you. So the moment you read the question, they're talking about it was coming direct downward. You have been given the initial speed, then everything will be negative. Okay? Yes, that's the only trick part. Yeah. That's the only trick part. But if they mentioned to say it was going direct downward with an initial velocity of 0, it's a normal way, the way we solve it. G will be positive. Put velocity positive. Nothing is going to be affected in that case. But in most cases, they will give you the initial speed. So everything becomes negative. Okay? Now, let's go ahead and also talk about this interesting question, which is question 14. So, as usual, we have first to come up with a free body diagram. Like I said, let's first read the question. A stone is thrown from the top of the building. Okay? A stone is thrown from the top of the building, giving an initial speed of 20 meters per second, straight upward. So, this is a different scenario. You have got a building, then you throw. This is the person here. This person throws a ball, a stone. Now that stone goes straight upward. Now they are saying that the building is 50 meters. Okay? Another thing which you have to take note is that Then the stone just misses the edge of the roof on its way down. So as it reaches at maximum height, as it was coming, instead of it just coming here and come here, then it misses. So it went there and come down there. Okay, it reaches down there. So once it reaches at that point, from that point to that point, that will be the maximum height reached by the stone. Perfect, right? So the question is determine the first question is determine the time at which the stone reaches its maximum height. So we want the time from where it was thrown all the way to the maximum height there. So it was going up. What will be the data? G will be what? G will be what? It will be negative. The velocity we have been given, which is 20 meters per second. But the final velocity when it reaches at the maximum height, what is the final velocity? Is 0. Then I want to find the maximum height. I think the third formula, I want to find the time. Yes, I want to find the time. I can use the first formula where we are saying V final is equal to V initial plus GT. So the final is 0, the initial is 20. So it will be negative 9.8 T. Shift 20 to the other side, negative 20 is equal to negative 9.8 divided by times T. So we are dividing by 9.8. Then T at that point will be 20 divided by 9.8. What are you getting? Since you have a calculator there, 2 point. Yes. So you can just say 2 seconds. Just like that. Any question there? It's clear. Then we can go to part B. So 2.04 is our time. Another question, the maximum height. So since we have everything now, so I don't think this will be we have the time, but I want to explain one thing. Here I can use this formula, H is equal to V initial times T plus half GT squared. But okay, let's first find the answer. So the maximum reached by the stone is going to be maximum height. The initial velocity is 20 times 2 plus half. The G is negative 9.8. Then T is also 2, but we square it. So the H will be 2 times 20 is 40. So it will be minus, I have got 2 squared times half divided times 9.8 is 4.9, which is 19.6. So the maximum height reached by the ball, I'm getting 20.4. Can you confirm? Confirm that one. Okay. Then I wanted to explain something. 19.6, I did half times 9.8 times 2 squared. Try. So 0.5 is half times 9.8 times 2, then square it. 19.6. Is that okay? So that's the maximum height reached by the ball, by the stone. You're okay there, right? Okay, so now another thing is I told you to say the time is going to take from this point to that point. The part C is saying determine the time at which the stone returns to the height from which it was thrown. What are we going to do? Determine the time at which the stone returns to the height from which it was thrown. So you throw the object there. The time is going to reach at this point here. What will be the time? Hmm? It's not confusing you because I told you to say the time from A to B is the same as what? So it's the same thing here. We have already found the time from A to B. Now we want to find the time from B to C. What are we going to do? Yes. So 2 times 2. That's the answer for part C. I don't know if you're confused still here. I think I explained, but yes. So I explained here the question. They were just saying to say determine the time at which the stone returns to the height from which it was thrown. So the time you throw the ball and the time is going to reach, it's going to be the same time from the time you throw the ball when it reaches at the maximum height, same as from the maximum height to where you are. So you just do times 2. So 4 seconds. Yes, boss. Any question? The velocity of the stone at this instant. What does it mean? When we say the velocity, so they're just asking to say anyway, they were just this question, the way they were supposed to ask it, they were supposed to ask in this quest. They're supposed to ask in this way. The velocity at which the stone was reaching where that person was when throwing that ball. So you know when you are throwing something going up, okay, that initial speed 20 meters per second, the same initial speed when it reaches at that point, now the opposite of that sign, meaning the time is going to be reaching is going to be negative 20 meters per second. But if you are not convinced, we can solve and we'll be able to find the same answer. We have the maximum height as 20. Now, at that point, when it is starting from this point, the initial speed, we are going to assume that it is 0 because at that point it was 0. So it was coming down. I want you to go ahead and use this formula. You'll be able to find negative 20 meters per second. This one. Now, G will be negative in that case. Okay? So you plug in the values. So G will be positive since it's going toward the gravity. So you plug in the values, you discover that you have 2 times 9.8, then times the D is 20. 20.4. Okay? So try. What is 9.8 times 2 times 20.4. I'm getting 399.8. If you round it off, is 400. So you have v squared is equal to 400. What is the square root of 400? Is 20. So now, since it's coming down, you have to show that it's negative. So it's negative 20 meters per second. That's why even if you don't solve, you just tell them to say the same velocity it was going with, it's going to be the same velocity it's going to reach with, but it's going to be the opposite. That was positive, that is going to be negative. As simple as that. Yes. Then the last question is saying the velocity and the position of the stone when t was equal to 5 seconds. So when t was equal to 5 seconds, what was the velocity? Okay? It's the same thing. We don't have to struggle here. So to find the velocity when t is equal to, you have been given the time, you use the same formula. V final is equal to V initial plus gt. So it's going up, the g is negative. So the initial speed you have been given is 20. It will be minus 9.8. The time is 5. So what will be our final velocity when t is equal to? So you have 20 minus open brackets 5 times 9.8. What am I getting now? So 9.8 times 5 is 49. So if I do 20 minus, so I'm going to get negative 29.0 meters per second. When you see negative, what comes in your mind? Does it mean that when t was equal to 5, the object was still going up or it was coming down? What comes in your mind? Why? The velocity, we have found that the velocity is negative 9.0 meters per second. So I explained to say why was it coming down. Exactly. So when the velocity is negative, when you're talking about the motion in y direction under free fall, then that object was coming down. But remember, you and I, we have agreed that the instant that ball was, the stone was reaching at where that person was, it was negative 20 meters per second. But now it is when t is equal to 5. Do you think it has already passed at point C at that point, or it is before that? Come on, come on, come on, come on. The question is, we are saying that when t is equal to 5, the velocity is now negative 29.0 meters per second. Does that mean that we have already passed where that person was, or we have not reached? What can be the best answer? We have not yet reached. But we said reaching at point C, what is the time? It's 4. But now we are talking about t is equal to 5, meaning we have not reached. Yeah, we have already left. That's the reason why the velocity is now negative 29. Because when t was equal to 4, the velocity was negative 20. Now it's negative 29. So we have already passed. So what is the position? When the question is asking about position, they're asking about the displacement. So you use this formula. D is equal to V initial times T plus half gt squared. You have everything. When it is coming down, what comes in your mind? The g is positive. Thank you. Meaning I have got d is equal to, the initial is 20 times time is 5 plus half g 9.8, t is now what? T is 5, but I square. So 20 times 5 is 100 plus, okay, just a minute. I want to emphasize on something. You know, we are saying we are using this 20, but do you know that this 20, it is this initial velocity which this ball was using when, or the stone was using when going up. So in short, we are getting everything at the point of the initial when it was going there. Have you seen what because I've plugged in 20, meaning I'm starting from A. Have you seen there, right? Meaning G has to be what? G has to be negative because I've started from point A. Unless if I started from point B, I would have gotten B to be, G to be that one. Okay? So I've gotten it from point A. G is going to be negative. Yes. 5 squared. So I have 0.5 times 9.8 times 5 squared. That is, so I'll have d to be equal to 100 minus 122.5. D will be equal to negative 22. Negative 22.5 meters. Just telling us that it was going down, therefore the displacement is, the position is 22.5 meters. That's the basic idea behind freeform motion, unless you have got questions, but I can say for freeform motion I'm done.